Hello everyone, a warm welcome to this virtual training series on developing solutions for Microsoft Azure. I'm Monica from TechnoFocus and I will be serving as your moderator today. We're glad to have Tiago Costa with us, who will be presenting today's session. He is a Microsoft certified trainer, a Microsoft MVP, and cloud architect and advisor. He is currently based in Portugal. Before we get started, let's have our housekeeping announcements for the day. If you happen to face any audio or video issues during this broadcast, please let us know through the Q&A panel. If you have any technical questions, please post your queries in the Q&A panel and we will do our best to respond to them in real time. Please note that this training program will also be recorded, and the recording will be available for on-demand viewing approximately 48 hours after today's broadcast. Now I'd like to turn today's event over to our presenter. Tiago, you have the floor.
Hi, welcome everyone to this virtual training series about developing solutions for Microsoft Azure. So we already covered on the previous day Azure virtual machines. We also talk about how can we build them, how can we manage virtual machines, and then we went to talk about creating container images. We talk about containers, container registries, and also how we can run container instances. Today is a day that we are going to focus on developing for Azure storage. So we are going to talk about developing solutions that will use blob storage, so Azure storage accounts, and then we're going to focus on the blob storage. And then we also have some topics around NoSQL, namely we're going to talk about Cosmos Db. But we don't stay here, so we still have 3 other days ahead of us. And on the next few days, we're going to talk about developing Azure web apps. We're going to talk about logic apps, function apps, API management. We're going to talk about identity with Azure AD. And we're also going to talk about how can we secure our applications, and then of course securing Azure storage and also using an amazing service that is Azure Key Vault. Last day, it's all going to be about monitoring and creating instrumentation, so getting telemetry data from our applications, and then we're going to see how we can cache data and also use content delivery network solutions. And the last bits of that day, it's going to be about how can we develop message-based applications and event-based solutions. So also a very, very interesting topic. So, but let's get started here, and let's get started to talk about developing for Azure storage. So first of all, we need to think about that. Well, we need to look at our data and see what type of data are we talking about. So we need to classify our data, and for this we can easily identify 3 types of data. The first one is structured data, semi-structured data, or unstructured data. So what is structured data? The structured data, sometimes we refer that to as relational data, is data that adheres to a strict schema. So all the data has the same fields or properties. The shared schema will allow this type of data to be easily searched with like SQL, for example, so the structured query language. These capabilities make this data style perfect for applications like an RP, a CRM system, an inventory management. And usually we're going to store those in tables, and then we're going to have several tables that becomes a database, and we're just going to basically have that database that has tables. Tables will have rows, columns. We can then have keys there. We can have a primary key, a secondary keys that have relationships between several tables. So all of this is what we can call structured data. Then we also have semi-structured data. So this one is less organized than the structured data, and it's not stored in a relational format. basically the fields are not neatly fitting to tables, rows, and columns. So the semi-structured data usually contains tags that make the organization and hierarchy of the data apparent. For example, key value pairs, something like that. Semi-structured data is also referred to as non-relational or NoSQL. So the expression of structured of the data in this style is defined by the serialization language that you're going to use, like XML, JSON, just two examples. And then we have the last one, which is what we call unstructured data. So when we talk about unstructured data, usually we're talking about like pictures, movies, basically a container image, all of that data that would just basically drop into a file share on-prem. We have in our hard drives like music, videos, pictures, so all of that kind of data that we also need to take care of, like a PDF file, a Word document, so something like that. And of course we also need to manage that. So those are usually the three categories that I have when it becomes to when we are talking about classifying our data. So when you decide what storage solutions to use, think about how your data will be used, how often your data will be accessed, is your data just read-only, does the query time matter, and then the answer of all these questions will definitely help you decide on the best storage solution for your data. Okay, so this is what we have here. Next, it's about exploring some of the Azure storage services that we have. So I have Azure storage services like Microsoft Azure storage accounts. And storage accounts is a managed service that can provide me a durable, secure, and scalable storage in the cloud. Okay, so Azure storage comes with 4 types of services included: blobs, files, queues, and table storage. Blobs is a massively scalable object store that you can use to store text and binary data. Can include support for Azure Data Lake Storage Gen 2 or regular blob storage. Then we have files. It's a managed file share for cloud or on-prem deployments. So the big difference that we have between blobs and files, and there's like some confusion about this, is that blobs, it's only accessible through REST. So you have a REST API, and if you want to access, you have to use the REST API. What about files? You also have a REST API, but adding to that, we also have an SMB share. So we have an SMB connection. And that's quite cool because I can basically map that drive in a Windows virtual machine or even in a Linux virtual machine, and then they will access through the SMB protocol to our file share. So that's a big advantage, and that's very, very, very used, okay, when it comes to, for example, bringing on-prem environments on virtual machines to Azure, and we need a quick lift and shift. So that's very, very useful over there. Currently, Azure Files can also be connected with on-prem, so you can even have Azure AD authentication authorization on this, or also using the traditional Windows Server Active Directory. Users that are on-prem that can also work with this. Then I have also other 2 services. Like I said, I have queues and I have table storage. So when it comes to queues, it's a message store that we can have reliable messaging between applications. So I can create a queue, then I can add messages to the queue, and I can have another app that will read messages from the queue. This is very common when you want basically kind of like create, imagine a web front end and then a worker, and you can create, and you want to create like a disconnected environment from each other because you don't want to have a dependency on the front end about the worker, because if the worker is not working for some reason, the front end will have an impact if they are just connected directly. If they are indirectly connected through the queue, basically the front end just needs to drop messages in that queue, and then the worker, when it's ready, it goes there and he also reads what you have there. So you have this advantage, and also others like load balancing the load that you have on the worker, because the worker will just read one message, will process that, will read another message, will process that. It will not be flooded with requests from the front end in case of that happen. So there's also certain patterns that it's very common to use queues in Azure. Then another one and last one is table storage. So table storage very simply is a NoSQL store for schemaless storage and of structured data. So we're not going to cover table storage in this module, but it is a great way to get started, and then maybe later you might need the performance and also the features that you can get from Cosmos DB. Cosmos DB, it's a great NoSQL approach. It has tons of features. It can go to performances that we're talking about millions of requests per second. It is truly amazing, but comes with a cost. Sometimes, look, we have something that it is just simpler. We don't need that much complexity, and so we might use just table storage. It might be enough for what we have. So Azure storage accounts are needed, okay, to create that namespace for all those services. So usually we start to create an Azure storage account, and then inside our Azure storage account we're going to have all those 4 services available to us. Then we need to decide, how many storage accounts do I need? And that's always a very good question when I'm designing an application. Sometimes I can just say, hey, yeah, I just need 1 storage account. Then you tell me like, hey, I can create blob containers and divide my stuff to blob containers. Yeah, it will work. Not saying no to that. But then you need to ask yourself, in terms of performance, a single storage account comes with limited performance. It is by default 20,000 IOPS per second. Then you can tell me, oh, but I can even increase this a little bit. Yeah, for sure. Yes, you can increase a little bit. If you ask, support can go up to 50,000 IOPS currently. That's great. Yeah, but still, it's a limitation. So what I do is I try to create several different Azure storage accounts based on the applications that I have, and also based on the environment of the application that I have. Also, a single storage account will be bound to a location. So if I need to have data in 2 different Azure regions, well, I need to have 2 storage accounts. If you also need to have 1 storage account in 1 subscription, and in another subscription you also need to use some kind of storage account there, well, again, storage accounts do not span across subscriptions, so you also need to create another storage account over there. So I already told you 3 reasons that are like the main reasons, which is different subscriptions, different regions, and also performance. But of course, security is always a concern. Sometimes you want to give permissions to 1 storage account and not to the other. You might still have legacy applications that they're using access keys and they're still not using role-based access control on the storage accounts. So you might also need to create a specific storage account for those cases. Okay, so that is something that we need to think about. Also, because of cost, when you create a storage account, you create you're asked what is the replication model for that storage account. And imagine I choose premium local redundant storage because I really need the performance. And then on the other one, I said, yeah, I just don't need this data. I don't need that much performance. Like, imagine backup. So I'm like, yeah, don't need that. So are you going to put that data inside that premium storage account? Not very clever idea. You just should create a brand new one that uses standard local redundant storage, and you just drop your backups there, because that probably it's more than enough. You don't need the performance. So those are just another example, okay, on why we should create another storage account. And you do not pay per storage account. You pay for the data that you add to a storage account and to the transactions that you do on that storage account. But when we talk about storage in Azure, we're not only talking about storage accounts. We're also talking about Azure SQL databases, which is a managed SQL server experience. We are also talking about Cosmos DB, which is a NoSQL approach. We are also talking about Postgre, okay? We're also talking about MySQL. So all of those become also part, and also event hubs like we see here. So all of those becomes part of the umbrella that we call Azure storage. Okay? But then of course, yeah, storage accounts is also part of that. So let's do a demo. Okay, let's do a demo, and the demo will be exactly on that. So what I'm going to do is I'm going to create a storage account using the Azure portal. And then, well, how can I create my storage account? Well, I can go to the portal. I can use Azure CLI, which is using Bash, or I can use PowerShell. I can use a management client library. I can use Fluent API with C#. I can even use an ARM template, or even using third-party tools to manage this like Terraform. So things like this, okay, they're all possible to be created in a storage account. So now it's time to create an Azure storage account. So let's go for create resource, and we're going to just start to type storage account, and we find here storage account. We click create, and then we just basically shows up the create storage account UI experience. The first thing that we need to select is the subscription. So if we click here, we can see more than one subscription when you have them. In my case, I only have this one, and I want to create your resource group because I don't have any resource group available for this, so I will just create a new one. And then under the storage account name, so this is where we need to create your unique name for your storage account. That name needs to be globally unique, and when I say globally, is really globally. It's not just within your subscription or within your tenant. No, if I create a storage account that is called my storage, no one else in the world can create that same name on their storage accounts. And you're going to see why, because then we have endpoint for like blobs, that is the name of the storage account, .blob.core.windows.net. As you can see, yeah, this is a public endpoint, and of course, well, no one can have that name again, because that is reserved just for me. So that's the first bit. Then I just did my storage as the name. As we know, this is not unique, and you see that we get exactly that information here, saying, well, storage account name, my storage, it is already taken. So okay, so we basically need, okay, to do this in a different way. So let's just put AZ videos 1, 2, 3, 4. Okay, great. it was accepted, so it is unique. There is none with that name. And then I can select the location, have the list of all the regions that I have available for me. Then I can choose what is going to be the performance, standard or premium. Then I have the account kinds. So the account kind, it's a little bit tricky because we have several of them today, but we advise now people by default to go for storage v2, which is general purpose v2. Why I'm saying go there? Because when Microsoft adds new features into Azure storage accounts, they're usually only available on storage v2. So that's where you get all the cool new features, etc. They are going to be basically hosted only on storage v2. We also have storage v1, which is the legacy kind that still is fully supported security-wise. They get all the patches. They are fully managed. There's no difference, okay, whatsoever on that part, but they don't get the new features, okay? So that's what we have. And we also have blob storage, and we also have other premium, specific for premium accounts that are for blobs and for files. So each one of them has their use case, where and when to be used, but usually the most common one today will be created in storage v2. Storage v1 and blob storage, so the ones that we talk about. If I tweak this to premium, you see here that v1, v2, they're still here, but then it just shows up here blob storage and file storage. So those two account kinds, they are exclusive for premium. Also, we're going to cover this in a moment, but for premium, you see that it's only local redundant storage available, but if I go for standard, you see that I have quite a few others in here. I'm not going to enter into details into this right now because we're going to cover this in a moment. Then I have networking, data protection, advanced tags. So all of this, again, some of these things we're also going to cover. So I'm just going for now straight to review and create, and I'm just going to click create. Now deploying a storage account usually takes something like less than 30 seconds, so no more than that. And then yeah, we're going to have a storage account available for us. So for now, let's just wait for this to finish, and then let's review our storage account. Here we go. It is created. So if I click go to the resource, so we see here our resource, and we see that I already have here containers, file shares, tables, and queues as services. So I can easily go to containers. This is the blob storage, and like create here like containers. Let's just call this demo. Click create, and there you go. Okay, now I have a container. If I click on the container, I can start to upload things in this. I'm using the REST interface when I'm doing this. Well, the Azure portal has coded, okay, to use the REST interface, but yeah, it's what we're using. If I want to build my application, I can build a custom application that will just interact directly with this and will just upload basically some blobs like a PDF, video, music, images directly into my storage account using the container service. So this is how we can create a storage account using the Azure portal. So in order to interact with Azure Storage, Azure Storage provides a set of REST APIs that we can use to see data and to upload data to the Blob service, to queues, to tables, and to files. With files, we also have the option to have traditional SMB file share or more modern NFS. That's a recent adding to the service. But usually, if we're coding something, yeah, that's what we want to use is this REST API, and that REST API will work with basically, well, every single language that supports to do a REST call, because that's basically what you have to do. But of course, Microsoft thought about all the developers out there and they created a set of client libraries that can save significant amount of time for us when we're coding an application. And currently we have several client libraries that support a number of languages and frameworks that can include .NET, Java, Python, Node.js, Go. So all of those are supported, and we have SDKs that have those client libraries that makes the life a little bit easier when we are coding and we are accessing the data that we have, for example, in a blob container. So how do you connect to your storage account? So we have several ways to connect to our storage account. I can just use the access keys. So every storage account has a key 1 and a key 2. So using those access keys, yeah, I can just connect and have access to my storage account. In addition to the access keys for authentication on the storage account, I also will need the storage service endpoints where I'm going to issue the REST calls. Usually this will be a combination of the account name dot, and for example, if it is for blob storage, it will be name of the storage account .blob.core.windows.net, and then of course then the name of the container, and then the name of the blob you want to access. There is also a simpler way for you to use this, which is just use a connection string. So this is probably the simplest way that we have to do this. So in code, we just need to say, hey, this is my connection string, and all you need is that, and it will basically just connect to the storage account. Basically, that connection string already comes there with your account name, and already comes with your account key, all defined inside the connection string. But so basically, already has all of that you're going to have there. Another alternative that we have to access this, because we know sometimes I don't want to share an access key with someone or something like that, so I can also do and use another model which use shared access signatures. So with this, I basically can create this shared access key. That shared access key will need to be defined a time limit, so when that key is going to expire. It also defines the permissions that with that shared access signature you're going to have, so you can limit it, the access of that shared access key, and then you just need to give a URL with that shared access key, and you'll just have read access, for example, for a certain amount of data without the need to authenticate, without the need to have a key and a REST endpoint, and even to code things. This you can just put, just give this to someone just clicks on that link, and the browser will do the REST call for them. So there's literally no code that needs to be written in order to make something like this work, as long as you give the SaaS signature already to that person. Let's just do a demo, and let's just add a client library to my app. Let's add some storage configuration there, and let's connect to my storage account, and let's just see how can we read data that's there, and how can we upload some data that we have in our storage account. Okay, so it's time to create here a small application in order to interact with the Azure SDK for Azure Storage. So I'm just opening Visual Studio. I'm going to create a new project here, and I'm just going for a console application, so nothing fancy. Let me just check if I chose your console app. Okay, and I'm just going to drop this here under projects demo, and I'm just going to call this AZ storage demo, and let's create this. So now this is creating the project for us, and the next step it will be creating and adding here a Nuget package. So I'm just going right click, manage Nuget packages, and I'm just going to search for the Azure Storage Nuget packages. So let's just search for Azure Storage, and we have this Azure Storage Blobs Nuget package. That's exactly the one that I want. It will install some other associated packages. We just say yes, and this is being okay, it is being then installed. Then, well, I already know that I need to use here the system.io namespace for other stuff, and I also need then to call here Azure Storage.blobs. So this will be the one that I will need to interact with this. So now let's just remove this yellow world thingy from here. Let's just put like Azure Virtual Training Days Storage Demo, just so that we can have something in here. I need string, and I'm just going to put here my connection string. This is the connection string from the Azure Storage account, and let's be honest, in a real project, this should be done in a different way. This connection string should not be hard coded side by side with the code, but this is just a demo, so I'm just going to do this. Let's get here to our Azure portal. This is the storage account that I want to interact with, and if I go to access keys, you can see here I have connection string. I can just copy this connection string, and I just need to drop this connection string in here. Okay, so now that I have this, and I have already the connection string taken care, I need to create a object that is from the Blob container client, and let's just basically call it container client. And to do this, I just need to do equals to new Blob container client, and then I need to pass here my connection string, and I need then to pass here, okay, what is the container name that I want for this, and I'll just call this AZ training. So we have this basically this connection for that Blob container. That Blob container does not exist, so let me just go back to the Azure portal. We could do this by code too, but I prefer to do it in here. So I'm just going to put there AZ training, and I'm just going to create this. And of course, if we click here, it's empty. Of course, we just created, right? So it is empty. So now let's get back to our code in here. So I already have a reference to that Blob container. So now what I need to do is create a reference to the Blob, and so this, I will just call this Blob client equals to Blob, and then I will just use the container client, and then I'll just say get Blob client, and then I need to pass here, okay, something like a name like sample file, for example. Now that I have this, I can then do like using file stream. This is why we use the system.io in the namespaces, and I'm just going to do equals to file dot open read, and now I'm just going to pass here a path, and the path that I have is C, okay, underscore data. So this is a local path that I have in my machine, AZ copy, and then I have something here called demo file. Okay, it's a text file, this one here. And after I do this, so right now I just need to do blob.upload, and I will upload the file, okay, that I just made a reference over there that I'm opening with the file stream. So if we do this, if all the code that we wrote, it is correct. So if I do Control F5, so start with debugging, you should see here the console application showing up. There you go. You run, press any key to continue. So didn't give any errors. I didn't did even a try catch on this, but this is good. So now if we go back to the portal and I refresh this, okay, we should see here our blob. So if we wait, there you go. Our sample file here is here. Okay, so this is the remote name that we defined. Okay, and so this is our blob, 45 bytes. So it is okay. So this is how we can very easily just write some code and just upload our blob into an Azure storage account. So now it's time to see how we can develop solutions that use the blob storage. So for doing this, we need to understand a little bit what are blobs. And blobs are pretty simple what they are. They are files for the cloud. This is the expression that I like to use. So apps that work with blobs, they will work with them in same way that they work with files on the disk, like reading, writing data. However, unlike a local file, blobs can be reached from anywhere with just an internet connection. So an Azure blob storage is what we call unstructured, means that there is no restriction on the kind of data that it can hold. For example, a blob can be a PDF file, it can be a photo like a JPEG, PNG, can be a video, it can be an XML file, JSON file, a markdown file, you name it, okay? So a blob is not limited to a specific format. You can just host whatever you would like to have. And a blob can contain kbytes of data, but it can also go to gigabytes or even terabytes of data. So and of course, well, we're going to use them a lot, right? In applications that are cloud native, because we don't need to have an infrastructure like based on virtual machines and disks to store files and things like that. No, we can just create a storage account, we create a blob container, and then, well, we just put our data there, or files, our PDF files, etc., all of them over there. And then the great advantage that we also have with this is that blobs and containers, they support metadata. So it's basically name, value, string pairs. So it is quite cool what we can do with this, because, you know, it's just not a space where I just put some files there and then whatever, right? I can also create knowledge based on those files. So with that name value, you can create like tags and things like that. So it is quite cool what we can do. And like we already saw, then we have the blob storage API REST, the REST API that, well, it has support to upload a file, download a file, do all of those kinds of things, but also to interact with that metadata that we created. We can do queries like, hey, I want to know all the blobs that I have here with the name this with this value, okay, with a specific value. So I don't know, like a department, HR. So I can only see files that are basically blobs that are around the HR department. They are from the HR department because, well, we tag them like that. So this is the kind of stuff that we can do. So it is quite cool, the stuff that we can do with this. So in order to understand a little bit better blobs, we need to understand that there are three different kinds of blobs that I can store data in. And they are block blobs, append blobs, and page blobs. Block blobs are composed by blocks of different sizes that they can be uploaded independently or in parallel. And usually we use this types of blobs, okay, for files that we need to do like streaming. Like, for example, imagine I want to do a video. Well, you know, you're going to read from the beginning to the end of that file, right? So this is for basically for files like that, like a PDF file, a text file, etc. Then I also have append blobs. Those are specialized block blobs. So they're still from the block blobs, but they're specialized. And they basically support appending new data. Okay? So these are basically tuned up for data that needs to be added to the file, and more data needs to be added to the file, and more and more and more. So this is a great example, is scenarios for storing logs or writing streams of data, because you just need to add more data. Then the last one, page blobs, they are designed for scenarios that involve random access reads and writes. So a great example is when you're using unmanaged virtual hard drives for Azure virtual machines. So you need to do random reads and random writes, right? It is quite the thing that you're going to do. So those are the great examples where we can do page blobs. Designing a storage organizational strategy. So when designing an application, we need to store some data. And the first thing that I start to think about is, how is the app going to organize the data across storage accounts, containers, and blobs? So storage account is flexibly enough to organize your blobs however you like, but you should use additional storage accounts if needed to separate it logically, the costs, or even control the access to, in cases that you still have a cloud native approach but still a legacy cloud native approach, because you're not using the like, for example, resource based access control for storage accounts and things like that. So I can also do a container. So I create a container inside a storage account, and when you do a container inside a storage account, that can be your boundary. You can put a security boundary on the container, so I can have access to a storage account, but I will not give you access to all the containers. I can give you only limited access to a specific set of containers. We can do this with role-based access control for containers. It's pretty cool. If you still use a legacy approach, like I was saying, that you just give the connection string or just the secrets to an app, and that app then can come here and they can basically do everything, that app. That app can see all the containers, can create containers, can delete containers, basically can do everything. Probably not a very good idea, okay, nowadays, because we have role-based access control for storage accounts, so it might be useful to do this. But sometimes we still have, because that was the only option a few years ago, so we still have a lot of applications that use that model, and they were not wrong. They are just outdated applications. We need to modernize them, but we know that sometimes it's not easy to do that. There are other priorities in the company, so we might need to create a storage account specific for those applications so that we don't have security concerns. Then we talk about public access on containers and some of the security boundaries. So some of them I've already explained. Public access, so you can create a container, and when you create a container, you can say that, oh, this container will have public access. So public access will be just for read. So for write, we do not have public access. So which is quite good sometimes, because sometimes you really just want to open the data that you have there. There are like pictures to show on your public website. It's like, who cares, right? I don't need to do authentication for that. You don't do authentication so people and your customers to get your public website just to see your company and what you do, etc. So you can and you should give public access to that. That is perfectly fine. For if you're storing like PDFs with invoices for customers and things like that, well, that we need to have that container as private. So for sure there it needs to be private, because having that information basically lying there in the public, it's for sure not a good idea. Then we need to choose a tool, okay, in order to be able to copy data. We already saw that, yeah, we can use the REST API We can also see the .NET storage client libraries that will help us with that. But I also have two amazing other tools, which is the AZ copy, which is an utility, a command line utility that is pretty good in order to transfer data between two storage accounts, between on-prem and a storage account, between a storage account and on-prem, and it can even get to other clouds, other storage from other clouds, this one. So it is a very amazing tool that we have here that we can put to work, and it will facilitate when we have those basically a task that we need to copy large volumes of data from one place to the other. And we also have the first one that is here on the slide, which is the Azure CLI. We already talked about PowerShell, Azure CLI, etc. But the Azure CLI also provides access to Azure storage through the AZ storage series of commands. They have basic commands to upload, download blobs between blob storage accounts and the local file systems. It's pretty cool that you can also use this. And I bring here some examples where you can see this. So you see here, AZ storage account create. Okay, yeah, I can just create a storage account using the Azure CLI. But then I can, okay, in that second example that you see over there, I can basically do an upload of a blob. And you see there, I want to do an upload of that blob. It's called my container. Okay, and then yeah, we can do that that upload. And also I can also do a copy, and you see there destination container, destination blob. Okay, and you can see there the source account key, the source container, and also the source blob, and we need all of this. So, and then, well, if you run those commands, yeah, you can easily transfer data to and from storage accounts. It's pretty cool what we can do with this. So let's do a demo now where we can see how can we interact with an Azure storage account using Azure CLI commands. We have here the Azure portal. It's open on the storage account that I want to use. And we're just going to upload some blobs using the AZ CLI. So first I need to go to containers, and let me just create here a container. Let's call AZ CLI, for example. Public access level for this is private. Good. And we have here the AZ CLI. As you can see, just newly created. Of course, it is empty. So now let's just minimize this, and let's just now here in Visual Studio Code, I'm just going to write a small script. So I'll just go for AZ storage, okay, then I'll go for blob, and then I will just say upload. So upload, and then I have to type here, okay, what is the account name? And I go for this AZ videos 1 2 3 4. That's the name that I had. And then I go for the container name. So the container name was AZ CLI, and I want to upload something called demo file .text, and so that's the local file will have exactly the same name, so demo file .text. And I'm also going to say here that the out mode, it's going to be key. And before I run this, I just need to put this in the correct folder. So there you go. As you can see here, I have that demo file over there. So if I select this and I run all of this, so it is being uploaded. There you go. And if we now move here, okay, to the Azure account, and of course I need to refresh this. There you go. Okay, we have the file in here. And look, I just did this just for one file as a demo, but of course you could just send a full folder, or you can send several files. You can, with using Azure Cli, so with Bash you can basically query the files that you want, select them, put them in the list, and then run this for the results that that you have. So this is pretty flexible, and there you go. So this is how easy it is to use the AZ CLI tools to upload a blob to Azure Storage. You can also move data using the AZ copy utility. So AZ copy is a command line utility that was specialized, created, and optimized for moving large volumes of data in and out of Azure Storage accounts. We can do bulk transfers from local file system to an to basically a storage account on the cloud, or from a storage account for on-prem. We can move data from blob storage to file storage. So all of this, it is possible to be done. So I can upload data. I can also then monitor my jobs because like I said, AZ copy runs asynchronously. So if you're transferring a large volume of number of files, it will start to upload. It will report the initial summary, but then it will basically still be running, and it can take a while to upload data. I have done huge transfers of data of like terabytes and terabytes of data, and kind of also depends on your internet connection for sure, but it will always take some time if you want to upload 1 terabyte of data to the cloud. You can also download data. You can copy data between storage accounts, and then there is where you can synchronize that data, those tasks. So it is pretty cool what we can do with this. But better than we being here in explaining what AZ copy is, let's do a demo. Let's do a demo, and let's move some data between basically to storage accounts using AZ copy. So we're back here in the Azure portal in our storage account. Again, I'm just going to containers. I'm going to click here to create a new container, and I'm just going to do AZ copy demo. This will be the name of this new container. And again, just come here. Yeah, it's empty. And let's just go to then okay, let's just go back here to Visual Studio Code. So now what I want to do in this case is I want to use the AZ copy utility to do this. So I just need to type AZ copy login, and in my case I'll just use here tenant ID that I have for my demos, so that I can do the login experience. This will open in here. I need to use this code, and I'll just press next. Okay, yeah, I'll use that account. So right now this should be already basically logged in, so we can close this one. So let's see. There you go, login succeeded. I'm just getting a warning that there's a new version of AZ copy. I have like, I think it's the 10.05, but that's fine. Okay, for our demo, that is not a problem. So I can just do now AZ copy, and I can use the copy command. And the copy command, I can just say, hey, look, copy this folder. So there I have a folder called AZ copy files. Okay, and I want to copy all that folder into a remote folder, which is HTTPS, and then I will put here AZ videos 1234 dot blob dot core dot windows dot net. So this is basically the endpoint for the blob storage account, and then AZ copy demo. So this is the name of the container that we just use. And then you just need to put dash dash recursive, and if we do this, so there you go. It already finished. The files that I had there is just 4 files. They're pretty small, and then you can see here number of files 4. Okay, so we have done this, so all the files now are there. So if we go here to the Azure portal now, and if we just click refresh, it will just show up. Let's see that. There you go. And we have here a folder called images, and we have some images in here. Have this text file. So everything was successfully uploaded into this storage account. So we already saw moving data with Azure Cli and with the AZ copy, but we can also do and write a .NET application in order to do that, and we can use the .NET Storage Client library in order to do that. So we need to connect to the Azure storage account. We can download blobs with this, we can upload, we can copy blobs between storage accounts, we can delete blobs, and we can iterate blobs into a container, so we can basically do some queries there. So there's like all the others, we have all these options then here. And of course, the advantage that I see in using the .NET storage client is that, well, you can really write something to your specific needs. When the Azure CLI, the AZ copy, of course, there are tools built for a generic approach. But in here, yeah, you can really write something for your specific use case. Then drop this code in an Azure function, drop this code in a web job or in another kind of automation tool, and let's just say, hey, run this every day or run this every hour, or even, well, have always this running and detect if there's like new data there. Hey, just run this, and it will basically copy some data and will do whatever you need for this to do. So let's just do a demo here and see how can we move storage blobs using the .NET storage client. I need string, and I'm just going to put here my connection string. This is the connection string from the Azure storage account. And let's be honest, in a real project, this should be done in a different way. This connection string should not be hard-coded side by side with the code, but this is just a demo, so I'm just going to do this. Let's get here to our Azure portal. This is the storage account that I want to interact with, and if I go to access keys, you can see here I have connection string. I can just copy this connection string, and I just need to drop this connection string in here. Okay, so now that I have this and I have already the connection string taken care, I need to create a object that is from the Blob container client, and let's just basically call it container client. And to do this, I just need to do equals to new Blob container client, and then I need to pass here my connection string, and I need then to pass here, okay, what is the container name that I want for this? And I'll just call this AZ training. So we have this basically this connection for that blob container. That blob container does not exist, so let me just go back to the Azure portal. We could do this by code too, but I prefer to do it in here. So I'm just going to put there AZ training, and I'm just going to create this. And of course, if we click here, it's empty. Of course, we just created, right? So it is empty. So now let's get back to our code in here. So I already have a reference to that blob container. So now what I need to do is create a reference to the blob. And so this, I will just call this blob client equals to blob, and then I will just use the container client, and then I'll just say get blob client, and then I need to pass here, okay, something like a name like sample file, for example. Now that I have this, I can then do like using file file stream. This is why we use the system.io in the namespaces, and I'm just going to do equals to file dot open read, and now I'm just going to pass here a path, and the path that I have is C underscore data. So this is a local path that I have in my machine. Az copy, and then I have something here called demo file. Okay, it's a text file, this one here. And after I do this, so right now I just need to do blob.upload, and I will upload the file, okay, that I just made a reference over there that I'm opening with the file stream. So if we do this, if all the code that we wrote, it is correct. So if I do Control F5, so start with debugging, you should see here the console application showing up. There you go. You run, press any key to continue. So didn't give any errors. I didn't did even a try catch on this, but this is good. So now if we go back to the portal and I refresh this, okay, we should see here our blob. So if we wait, there you go, our sample file here is here. Okay, so this is the remote name that we defined. Okay, and so this is our blob, 45 bytes. So it is okay. So this is how we can very easily just write some code and just upload our blob into an Azure storage account. When interacting with blobs, we can access several blob properties. Some of them have system-defined names, and those values are often set by the system processes. But we have other properties that we can have some control over them. Some we can only do a read operation, so there are read-only properties. When others we can do a read-write operations on those, like stream minimal read size in bytes, the stream write size in bytes properties. You can have the control to update also those values. When we have others, like for example blob type, remain days before permanent delete, etc., there are read only, so those properties will only be for read, so you can control the writes, you cannot update those, etc. And then of course we also have metadata. So blob metadata is user defined information. It's a name value pair, and you can control all of this using the REST API, using the SDKs, and you can do like doc type, test report, doc class public, doc class confidential, you name it, something like that. And then that data, that metadata, you can create some intelligence around that using like Azure Cognitive Search to index this, or you can even control access to files with this using some code that you write on your application. So let's do here now a demo where we're going to view blob properties and metadata using some Azure tools and code, and then we're going to do you're going to basically interact with that metadata. So we're going to add some blob metadata also using Azure tools and code. So we're going to consolidate all those two things in just one demo. So back again here in the Azure portal in our storage account, let's see how we can edit metadata and add metadata into our blobs. So I'll just go to containers. Let's just select this AZ training container here. We can do metadata at the container level or at the specific blob level. And you see here, this is the blob, but I could also do here, okay? If I do in this side here on the left, so this bit here, I'm doing this in the container level. But what I want is on the blob level. Usually it's where it makes more sense. So I can just open the blob, and then you scroll down in here, okay, you have some metadata, and I can just, like, for example, department, I don't know, like HR, and then I can put like classification, like public, okay, so that it's like public information, we don't care, and it just save, and there you go. Now you have those two. So it's like a key value, and just this doing in the portal, it is quite simple to do this. Of course, you can also do this with Azure PowerShell, with the Azure CLI, and also using the Azure SDKs, depending if you're doing this for .NET with C# or Python, Go, Java, you name it. So all the SDKs also support this. I don't see that many people using this, but this is quite useful, okay? When creating storage accounts that are blob storage accounts or a global general purpose v2 storage accounts, we can have access to something that we call access tiering on our data. So this corresponds to 3 tiers that we have. So we have auth tier, we have a cool tier, and we also have an archive tier. So we start to pay less money to store our data when it gets a cooler tier. Like, for example, I pay more in auth than what I pay in archive to store the data, but then I also have to pay for transactions. And in terms of transactions, auth tier, it is much less expensive than it is an archive tier. So we really need to balance very well where we're going to drop our blobs. Does it make sense to be in auth, cool, or archive? So what does it make sense to put in auth, cool, or archive? So let's start with auth. So auth is optimized for storing data that is frequently accessed. So imagine that you have an application, you're generating PDFs, and then you're interacting with those PDF images, videos. Yeah, that's auth tier. That's like a no-brainer, okay? You're just going to put there because you're always accessing those files. Over time, maybe some of those files, you just don't access them all the time, just one time here, one time there. So yeah, they're great candidates to go to cool storage. You're going to pay less money to store them. You're going to pay more money to access those. But did you access them all the time? No. So in the end, yeah, the two things together, and if you sum the two options together, when it is cheaper, when you predict that it's cheaper to go for cool, just go for cool storage. Cool storage comes with a very specific thing here. That is, when you move a blob from auth to cool storage, you're doing a commitment with Microsoft Azure that blob will be stored there for 30 days. What happens in 10 days if you make the decision to go back and move back that blob to auth storage? Well, you can do it. There's no limitation in doing it. But the thing is, because you did a commitment for 30 days, you need to pay the storage for those 30 days if you use it or not. Okay, so that's the commitment of those 30 days. And you can always access auth blobs on the fly, cool storage on the fly. You can, I want that blob, boom, there you go, you get it. Okay, so that one, you just get it right away. There's no limitations in performance, etc. What about archive? So archive is a little bit different. So archive tier, you really pay really a low rate to store this. The commitment is 180 days, like the one that we talk about for cool storage, and you really pay almost nothing, okay, to store this. But you cannot access the file right away. If you say, hey, I want to access that file, you need to do a process that's called a rehydration process that can take up to something like 12 hours to do this. There are options to rehydrate within an hour, but you need to pay more money for getting that. So it's a special rehydration process. But to be totally honest with you, we usually don't want to do this because what we put in archive data is storage and blobs that we are sure that we don't need them like in an urgency. Okay, so the other day I had a customer that they dropped backups in archive, and I was like, why do you guys have backups? Oh yeah, well, we almost don't use them, and if we need to use them, well, we just basically copy them from there. Yeah, but you know that it takes 12 hours. It never takes 12 hours, but it can take. That's the SLA. And they were like, oh, what? No, we don't know that. So backups is like a horrible idea to put in archive because, yeah, most of the times you never need them. Yeah, for sure. But when you need them, you need those files right away. You can't wait hours to start your recovery process. So yeah, archive is great for data that usually, you have like a legal requirement. Oh, you need to store this data for 10 years. But you know that after 2 years, no one uses that almost. It's really rare that someone uses that. So with this, let's do a demo here and let's change the default account access here from general purpose v2 or blob storage accounts, and then let's change the tier of a blob and let's see how this all works. Tiering is a great benefit that we have today with storage accounts. When we create a storage account, we can choose what is the default tiering, and we can choose for hot and cool. So archive is not possible to choose as the default one. But later in the game, you might have chosen in the beginning hot. It was what you wanted, but now you see, well, maybe I want to choose cool as the default. And if you have code that is uploading blobs and you don't explicitly say this goes to this specific tier, it will use that default one. So you might want to now move to cold. How can we do that later on in the game? So if you go to the storage account in the Azure portal and you open configuration under settings, you can then see here one of the options that says blob access tier. And as you can see, so this is the default tier. I have chosen hot because that's what I had during the creation phase. I can now change this to cool, and I just need to press save, and there you go. So now everything that I uploaded to this storage account, and if I don't explicitly say, hey, I want this to go to this specific tier, it goes to cool. Okay, so basically that's it. I can also, if you go back here to the overview and I go to containers and I will open here the container, you can see this here. Okay, so this is already in cool and you're like, okay, great, but I want this one specifically to be in hot storage. So what you do is you click here, okay, and what you're going to do is you click change tier, and then yeah, you can change the tier to hot or to archive for this specific file. So I'll just go for hot, just press save, there you go. Okay, so if we see now, so now this is in the hot storage. So you can do this per blob. Again, look, like I said before in previous demos, this is in the portal. You can also do this through code, through PowerShell, Azure CLI, so all those possibilities exist, but this is just a more visual experience to show you. But this is how easy it is to basically change the default account access tier and also change the tier of a specific blob. So with all this tiering that I can do, I can have hot, cool, archive. It's also nice to, if we could find a way that we could move some of our blobs automatically between tiers, because I don't want to have a user doing this, because let's face it, they have other things more important to do than moving blobs from tier to tier. So I can create what we call Azure Blob Storage Lifecycle. And that lifecycle, I can have rules and I can have some filters and then some actions. So I can just say, hey, all the blobs inside this container. That's my filter, is all the blobs on that specific container. And then I can then do some rule actions. And rule actions is like, oh, moving data that is not accessed for the last, I don't know, 90 days from odd storage. Let's move that to cool storage. That way, we still have access right away to the files, but I'm paying less money because look, no one is accessing this. So we can do that. Or I can even say stuff like, oh, and then after 1 year, move it to archive. And then after 5 years, well, just delete the files because we don't need to store those files to the infinite. So I only need them to store for 5 years. So you can put this kind of rules automatically in the Azure storage account. So this will manage all the life cycle for you. And we can do this very easily by the Azure portal, by using PowerShell, Azure Cli, or even through the REST API. So it is quite easy, okay, to do this kind of stuff. So let's do a demo and let's see how we can manage Azure storage lifecycle. Okay, so we're back here in the Azure portal in our storage account, and now we're going to see how can we create a storage lifecycle. So if we scroll down to Blob service, under Blob service, we have an option that says lifecycle management. So let's see what we have here. So this is the lifecycle management. I can add a rule. You just need to give your a name for your rule. I'm just going to call this demo rule. And I can then say, okay, what are the filters that I'm going to use for this? I'm going to do this with some filters or not? Then we'll have like a filter set or not. Or no, I'm just go for this for all the blobs that I have in my storage account. You can define which blob type, okay, blob subtype that you have in here. So then I'll press next. And now we can define here the rules. And I can say things like this. If a blob was last modified more than, let's just say 90 days ago, then what I want to do is move this to cool storage, for example, because I had odd storage. Now this is going to be moved to cool storage. And well, I can add this one, or I can even add an if block here. You can choose, instead of moving to a cool storage, you can say archive, or you can even say delete the blob. And this is how you build the rules. You can just come here, okay, and you do this. And of course you can add another if it is more than, instead of 90 days, like 365 days, so 1 year. I'm even going to delete the blob, for example, and things like that. So this is like super cool what I can do with this. And this, like I said before, it will totally automate the way that you manage the life cycle of your blobs, because I have cases that sometimes I have blobs that they should not be there for more than a year. 1 year later, we just don't need that data anymore, so we can automate the life cycle of that data using this. Before we had this, usually we had like PowerShell scripts, or we're using Azure Cli, or even writing applications to do this. But now we just come here and we just define this, and this is easier to do. It's a native experience. We don't have a cost running this, so it's all benefits in using this. So see how easy it is to create and manage an Azure storage lifecycle. So now it's time to talk about developing solutions that will use Cosmos DB. So what we get with Cosmos DB is a fully managed, global distributed, NoSQL database service. This service does not only guarantees global distribution, but also guarantees that at a low latency. All this because the service in its backend, it's all based on premium SSD storage, and that's one of the reasons why we can get that low latency. And if we see today's applications, they really require to be highly responsible and also to be always online. So to achieve low latency, high availability, instances of that applications, they need to be deployed in regions all across the world. And with that global distribution that we can get with Cosmos DB, this is one of the things that we can get with Cosmos. So applications also, they need to respond real time, sometimes to large changes, sometimes because there's a peak and we need to hyperscale during that peak. And again, Cosmos DB being fully managed, it will be able, okay, to do this because it guarantees global distribution, high availability, it guarantees low latency, and also guarantees single-digit multi-second response times and automatically instant scalability. All this in front, we can have several different kinds of APIs and SDKs for popular languages. In terms of APIs, so what we get is Table API, we get Cassandra, we get SQL API, which is the native experience, MongoDB, and Gremlin. And if you see, like, straight away, there is like 3 names that I can highlight here: Cassandra, Mongo, and Gremlin. They are big names on the NoSQL industry. So if you have an application today on-prem that is using Cassandra, for example, you can easily migrate your application to a fully managed service on Azure using Cosmos DB. So there's no need to install virtual machines and then manage yourself a Cassandra infrastructure. I'm saying Cassandra, I could have been saying Mongo or Gremlin, it will be the same thing. Then we have SQL API, which is a native experience, and we can also use Table API, which is very used if you are migrating basically a database that comes from Azure Storage tables. If you have that, like the other one, so you don't need to change any code, you just need to change the endpoint from your storage account to Cosmos DB and you're up and running. All your code will work in the same way. That's like amazing because we don't need to change anything. And of course you get scalability and all the new cool features that you get with Cosmos DB that you do not have in in Azure Storage Tables. Azure Storage Tables is a great service, don't get me wrong, but it's not for big requests. It's not for basically a workload that really needs the performance, it really needs the single-digit latency or globally distribution, because it is limited in terms of those features. And also feature-wise, for example, like having indexes and things like that, they also limit it. And when in Cosmos we have a little bit more flexibility on that. So it's a simple service. It's not a bad service like some people are saying. I don't like to say that because it's a great service. We have comprehensive SLAs. We guarantee the latency of less than 10 milliseconds at the 99 percentile. We have the globally distribution, and we have 5 well consistency models that I'm going to talk about later. So with Table API, you basically only have 2, which is if you're using local redundant storage or geo redundant storage. But in here, no, we have 3 more that can give us the feature that you are looking for. So like I said before, Azure Cosmos DB is a fully managed platform. So it's a PaaS service. And what I need first to create, when I create and I want to use the Cosmos DB, is I need to create an Azure Cosmos account. And I need to do this in my subscription. There are some limitations today. We can create a maximum of 50 Azure Cosmos accounts under a single Azure subscription. but please pay attention, this is a soft limit that, to be honest, usually you don't need more than 50, but if you need more than 50 in a single subscription, you can always open a support request that I'm sure it will be approved if you already have some Cosmos DBs. A single Azure Cosmos account can virtually manage unlimited amount of data and also provision the throughput needed for that. So it's the Azure Cosmos account that we get an endpoint, and you see there that account ID. It's going to be basically the account ID that you're going to get. You also have keys for your account, and based on that endpoint and that key, you can write code that can connect with your Azure Cosmos account, and then create database, create containers, create items inside your containers. So all of that can be possible. Also, when you create a Cosmos DB, you're also saying what is going to be the API that Cosmos account will have. And all the databases, all the containers inside that Cosmos account, it will use that API that you selected for the account. Sometimes it happens that we create 2 or 3 Cosmos DB just because we need different APIs, because we had some other workloads that were migrating and some bits were in one API, we're using one API, and the other ones were using another API, so we need to have different accounts just because of that. Still on the resource model, if we go for the container, so the container, I can also define what is the throughput that specific container will have. And for that, I can select 2 types. I can do a dedicated provision throughput mode, that basically the throughput provision on the container, it will be exclusively reserved for that specific container. Or I can do a shared provision throughput mode. These containers share the provision throughput with other containers that are in the same database, because you did on the database level. So basically you can define this on the database level, a throughput like, let's just say 1200,000, so 1200 RUs, and then all of them will share, all the containers will share that. Or you can just go to one of your containers and say no, so the 1200 is for all the other containers, but this container will have 2000 RUs just specifically for it. So that it's an add on the other 1200. It's 2000, of course it's more, but even if it was just like 400 exclusively just for that container, it will be an add on the other 1200. So in total you will have 1600 in that case. It's here that I also can define my partition key. I can also set up other things like the change feed for this. I can also set up the time to leave on selected items. So there's a lot of things that I can also do here on the container level. After the container level, so what I have is the items. But the items will be like JSON, documents, nodes, and of course I can also have and I can register stored procedures, I can register triggers, user-defined functions, but we're going to talk about those later here on this presentation. So request units. So let's talk about, because I already talked about, oh, it's a request unit, you have X request units, but what is a request unit? So a request unit, it's basically always per second, and it's the throughput, so the performance that we're going to have. I can reserve, like I said, throughput specifically for a container or for a database, and then I can share it between several containers. One RU it's equally to the approximated cost of performing a get operation to a 1 KB document using document ID. The number of those units that you're going to need for an operation will always depend on the size of the documents, the number of properties that your document has, because if it has more, it will be requiring more argues, and the operation that is being done. Get is basically a read operation, so it's the lightest one, but if you want to do updates or reads or deletes, it will be different. And of course the consistency model that you're using and the indexing policy that you're also using. All of this can and will affect the performance, but we need to provision our throughputs on our database, so we should understand how many RUs most of our common operations will basically consume, and understand that this is on a per second basis, and then understand then how many RUs do I really going to need at the same second. Because if we define 400 RUs, that's 400 RUs per second. So that's the performance of your database or your container. And so sometimes you might need more than that. I have customers that we have databases with 50,000, 70, 80,000, and that's why you pay more or less, because it's based on the performance that you can put into the system. So now let's talk about partitions in Azure Cosmos DB. So Cosmos, they use partition as a technique to scale individual containers in a database. So what happens is that the container items, they are divided into what we call subsets, that we call them logical partitions, and then logical partitions can be formed based on a value of a partition key. So because they have the same partition key, all of them go to the same logical partition, and we can basically partition this based on that key. Still on partitions, we have managing logical partitions. So when we have logical partition, that consists of a set of items that have the same partition key. For example, a container that we're talking about food nutrition. All items containing a food group property can be then the partition key. Okay, so if I have like meat or vegetables, basically we're going to different partitions. That logical partition also defines the scope of the database transactions, so I can update items within a logical partition. So I'll just affect a single partition. I can also do physical partitions, and when we do physical partitions, we're talking about a container scale by distributing the data and the throughput across physical partitions. Internally, one or more logical partitions are going to be mapped to a single physical partition. Typically, smaller containers have many logical partitions, but they only require a single physical partition. And unlikely the logical partitions, physical partitions are more an internal implementation of the system, and this is entirely managed by Cosmos DB. So it's usually something that yeah, it's good to understand how this happened, but we will not need, okay, to manage the physical partitions. I can also create what we call a syntactic partition key. So like we said, the best practice here is to have a partition key with many distinct values, hundreds or thousands even. The goal is to distribute your data and workload evenly across items associated with these partitions. Doesn't make sense to have one partition with 90% of your items and then have 200 other partitions with just the remaining 10%. If we can't find a property that will give you this evenly distribution, but you can construct what we call a syntactic partition. We can do this by using several basic techniques. We can concatenate multiple properties of an item. We can use a partition key with a random suffix. We can use a partition key with a pre-calculated suffix. So all of those basically will be able to use the technique of creating a syntactic partition key. Interacting with data using the appropriated SDK. So NoSQL data, as we already talked, is a super efficient way to store information that doesn't map the requirements of when we have like relational database. We can use Azure Portal. We can use the Azure Cosmos Db extension for Visual Studio Code. So there are like several ways to access your data, but of course, using an SDK to write your code and just going, for example, accessing data on a Cosmos DB SQL API, yeah, that will be the optimal experience, because then you can integrate this directly with your applications that you have. So this is exactly what we're going to do here. So let's just build a .NET console application and see how we can manage some data using the Cosmos DB SQL API. Now let's do a demo on creating a Cosmos DB account, a database, and then we're going to write an application to query this. So let's create a resource. Let's search for Cosmos DB. There we go. We click create, and this is the UI on how to create a Cosmos DB. So I'm just going to select this. I want this on the AZ videos, and I'm just going to type here AZ videos as the account name, and then the API. So this is where I can choose one of the different APIs that I have. The core SQL, which is the one that I'm going to choose, but I can also choose the MongoDB, Cassandra, Azure Table, or Gremlin. I'm going for this. I'm just going to select East US as the region where I want to create my stuff, and then I'll just leave all the other stuff by default, but here you could also define your geo-redundancy if you want it, or multi-region reads if you want to enable availability zones. This one, let me just enable this one so that you guys can see the difference. Basically, this is it. And I'm just now going for networking. On networking, I'm just going with the defaults. Then you can also define backup policies in here. What is the backup interval that you want for this? What is the backup retention? And you can choose in here. Encryption, I will use the service key to encrypt this, but if you want it, you could click here, create this, and we'll use your own key, so you can bring your own key for this. Then is the traditional tagging things, and then the review and create. In the review and create, I just want to call attention to this because Cosmos is one of the unique services that shows this. So creating a Cosmos DB takes a lot of time, and because of this, they are nice enough to show us here that in this case, the estimation time, it is 13 minutes. So they basically show this in here. So they are pretty cool to see this, so that you don't have an expectation that, oh my god, something went wrong, so I need to figure it out, what is the problem, etc., etc. No, it's in here so it is pretty clear for you this. So I'll just click create, and now this is going to take some time to create. So I will just wait for this to create, and then I will come back and show you guys this created. There we go. So we have this created, and if we go to the resource here, so we can see that we have our Azure Cosmos DB here created. So now the next step, it will be creating an application that will then interact with this using .NET and C#. So let's start to do that. Okay, so now that we have our Cosmos DB account created, I already created here. If we go to the Data Explorer, we can see that I created here just a to-do database, and I have here basically no items, okay, whatsoever. If I just open a small .NET application that I created, you can see here the app config, where okay, I have here the endpoint, which basically is the name of our Azure Cosmos DB account, .documents.azure.com, and I have here the primary key, and I'm showing the primary key, but of course, look, I'm going to delete this right after this, but you can't show this because basically with that endpoint, with that key, anyone can just enter, okay, into our Azure Cosmos DB. So be careful with that. I'm just going to change that right away. After this, so basically what I do here is I get the endpoint, I get the primary key, so I go and use the configuration manager to get this from the app settings, and I have here some variables more, and if we scroll down, so those are all the actions, all the methods that I'm going to call. So there is a create database, a create container, a scale container, basically so that I can interact with that, and then I have this add items, okay, to containers. That's what I want to show you. And if we see here, so I have here a family, this family, Anderson family, that has all these properties. So it has the parent, it has the child, which is an array, so you can have more than one child, and then this child here has a pet, there's an address, is registered. So I just created this, and then basically what I do is I do here a try where I basically just add, okay, I will just see if this is there or not, and if it is not, I will then edit that family to the basically to the to our as an item in our Cosmos DB. All this because I have this family, okay, class here that defines, okay, what's a parent, what's a child, defines also your an address, So all this is defined here in a standard plain old, okay, simple C# class. So then I do this. I have also another family here. That's the wake fields, and I do basically the same thing. So I generate this, and then okay, I have the second one, which is basically I'm querying, okay, this where I have a family that has the last name Anderson. So those are the two big chunks that I'm going to execute here. So if we see here, so I'm beginning the operations. There you go, creating the container, change the provision throughput. Then I created that item, I created the second item, and there you go. Then I did basically here the Anderson, so basically you just output that. Then I still do an update, then I can do still a delete, and the last bit here I basically delete this to-do list application. And you see the code of this. Let me just close this. We can see the code, and the code is pretty straightforward, okay? Like this one here is just a query. This is very simple similar to SQL query, okay? Just select star from C where last name equals to Anderson. It's really standard, to be totally honest. Then we do a query definition, okay, in here, and what we do is this query, okay, basically this feed iterator, okay, we just use the query definition, and then of course here we just create a standard .NET list of families, that we call it families, and we just iterate on this, and we just add families, okay, depending on the number of results that we get from there. And then I just did a console write line of the family, just that. This is why you saw that output in a very JSON way, but of course, look, we could always improve that by getting the individual properties, etc., and formatted that in a different way, but that's what it is. Then the replace the family is here. So as we can see, basically what we are going to do in here is that we just call this replace item async. That's the method that I need to call to do this, and I'm doing all of this because I'm using the SDK for .NET. So the C# SDK of Cosmos DB, and this is why it is so easy to interact with Cosmos. The last bit here, I'm just deleting. I'm deleting a family. Okay, so to delete a family, you just say it's an item, so you just call delete item. Okay, and async because it's an asynchronous operation, and we use here the await because of that too. But basically this is it. Okay, so this is how easy it is to create Azure Cosmos Db account, and then just write some a small piece of C# to create databases, change throughputs, create families, delete families, query families, and of course then also delete the database. As you can see here, basically that's the last bit that we're doing here. We're just changing the this .database delete the thing. Okay, so I hope you like this demo. I really like to do this because it's just so easy, okay, to see how we can do this with Cosmos DB. So like I referenced before, Azure Cosmos DB is a globally distributed database service designed to provide low latency, elastic scalability of throughput, and well-defined semantics for data consistency and high availability. The idea is that sometimes we need to have our applications with data that needs to be in different regions, and using Cosmos DB for those scenarios is highly interesting, because if we have a scenario where I need to provide Power BI reports for my customers, I can put my data into Cosmos DB, globally distribute this to several regions across the world, still maintaining IL responsiveness, still maintaining business continuity during regional outages, still maintaining low latency, and I can put the data closer to my users. So of course my users will have a better experience with this. And of course, well, if we have our data globally distributed, if we have an outage in one of the regions, well, we can always still rely on other regions that we have across the world. All of this, it's also backed by 5 well-defined consistency levels. Those levels include strong bounded statelessness, session consistent prefix, and eventual. Those levels are very well defined, they're intuitive, so what we do, and each level will have availability versus performance trade-offs. So, and each one of them also has their own SLAs. Sometimes if we go, for example, for a strong consistency level, of course, in terms of availability, yeah, for sure, that will have a huge benefit. Performance-wise, we will degrade performance because of that. If we go for eventual, yeah, performance will be very, very beneficial here, but we might lose some of the performance benefits that we might need. So stronger consistency versus weaker consistency, but of course more performance. We'll have a higher throughput if we go to an eventual. So basically this is what we have. So strong consistency offers basically a linearization guarantee. This refers to serving requests concurrently. So what happens here is that the reads are guaranteed to return the most recent committed version of an item. You never get uncommitted items or a partial write, users always get the latest committed write. If we go for just the other side of all of this, if we go to the eventual, there's no ordering guarantee for reads. In the absence of any further writes, the replicas eventually converge. So what happens here is that eventually consistency, it's basically the weakness, the weakest form of consistency, because a client may read values that are older than the ones you had read before, and eventually consistency is ideal where the application does not require any ordering guarantees. Example includes like count of retweets, count of likes, and things like that. Non-threaded comments. So if we have something like that, yeah, eventually it is a great consistency level, because we get the performance. If we are talking about SQL API and Table API, and like we're going to talk about also for Cassandra and for Mongo, Gremlin, there's always a question: is how can I choose the right consistency level for my specific needs? So in SQL API and Table API, for strong consistency, use bounded stainless consistency level. If we need stricter consistency guarantees, we can also use the bounded stainless. For eventually consistency, we use consistency prefix. For less strict consistency guarantees, we can use the consistency prefix consistency level. If we're talking about a highest availability and the lowest latency, we go for the eventual consistency level. If we're talking about a higher data durability, still without sacrificing the performance, in this case, we also might to basically create a custom consistency level at the application layer, which is also something that we can do with this. If we're talking about mapping between Apache Cassandra and Azure Cosmos DB consistency levels, because yeah, we need to do this mapping because they don't have the same names. So Cosmos provides native support for the wire protocol compatibility APIs for popular databases like Mongo, Apache, Gremlin, and also Azure Table Storage. They don't offer precisely the definitions of the models that we have and the SLAs, but we need to map them in order to get basically the best in Cosmos DB. Same thing happens here, okay, for Mongo and Azure Cosmos DB consistency level. So the right concern is mapped to the default consistency level that you configure on your account, because you can configure, by the way, a default one. Azure Cosmos DB then will dynamically map the read concern specified on the MongoDB driver to the one of the Azure Cosmos DB consistency level. Talking about containers, we already covered this, but just to resume, Azure Cosmos Container is the unit of scalability both for provision throughput and storage. Basically, a container is horizontally partitioned, and then it's replicated across multiple regions. Items that you add to the container and the throughput that you provision on it are automatically distributed across a set of logical partitions based on that partition key. Basically, that's what happens with this. That can be dedicated provision throughput, can be shared provision throughput, depending on the choice that we do. So with all of this, let's just do a demo where I'm going to create a container in Azure Cosmos DB using the portal. Okay, so we have here our Azure Cosmos DB easy videos, and in order for us to create here a database, I can just go to the Data Explorer, and you see here, yeah, SQL API. I don't have any database, but I have here. Okay, you can create here a new container or a new database. So we can just do this, and then we can just say people, for example, here. And of course we can define what is the throughput that this database will have. As we explained before, we can have several databases inside the same Azure Cosmos DB account and tweak each database to have specific RUs, or resource units, so the performance that we're going to have on our database. So I'll just go for 400. I'll just press OK, and this will then create here a database for us. So that database basically will be created for us here. There you go, people. And of course now, okay, I can start to create here basically containers and all of that inside that database. So this is how easy it is to create a database here inside a Cosmos DB account. So now let's see how we can implement server-side programming. So with Cosmos has a language integrated transactional execution using JavaScript. So when you're using the SQL API in Azure Cosmos DB, you can write stored procedures, you can write triggers, user-defined functions in JavaScript. So that JavaScript is the language where we're going to code this. You can write your logic in JavaScript that will execute inside the database engine, and we can do this using the Azure portal, or even using the Cosmos DB SQL API SDK. So what are the benefits on using server-side programming? So we have a procedural logic. So JavaScript has a high-level programming language that will provide rich and familiar interface to express business logic. JavaScript, very known language. People are used to write code in JavaScript, so there's not a big learning curve in order to do this. Atomic transactions. Cosmos guarantees that the database operations are performed within a single stored procedure or a trigger. They are atomic. This atomic functionality lets an application combine related operations into a single batch. Then we have performance. So the JSON data that is mapped into JavaScript. So it is intrinsically mapped into JavaScript, because even JavaScript, so if JSON means JavaScript object notation. So as for that, you can see it is like a native format for this. And then of course encapsulation, because stored procedures can be used to group logic in one place. Encapsulating this adds an abstraction layer on top of your data. So if you change something in your data layer, well, you can always adapt this encapsulation layer that you created. And then we also have triggers. And if we talk about triggers, they're pretty cool because we have pre-triggers and we have post-triggers. So pre-triggers means that they are going to be invoked when you start to do an operation, but this is before you do the operation. So imagine you're creating a new item. The pre-trigger will run before the item is created. And we also have post-triggers. They are similar with the pre-triggers, but they are associated also with an operation, but those run after the operation has been completed. So it has been completed, you get a response message sent to the customer saying, hey, yeah, this has done completely successful, and then is that the post trigger starts. So you can basically integrate this with your business logic. It is a pretty cool feature, I have to say. Understanding and writing stored procedures. So talking about stored procedures, like we saw, well, JavaScript, they are running JavaScript, and they can be created, updated. I can do read, I can query data, I can delete data inside a container by just calling stored procedures. So create an item using a stored procedure, for example. When you create an item by using a stored procedure, that item is inserted in Cosmos, in the Cosmos container, and an ID for the newly created item is returned. Then with that one, well, you can always get that in the stored procedure and even do some more stuff, like basically take that ID and have that ID in the response that you're doing for the client that is executing the stored procedure, etc. So we can do that. I can also support arrays as an input parameter for a stored procedure. So I can have like an array of items, and then you just need to basically query all that array and then well, just insert those items, for example, into a Cosmos container. I can also have transactions within stored procedures, bounded execution with stored procedures too, and I can also have asynchronous await with stored procedures. So all of these are features that, yeah, we support them in Cosmos DB today. Then we also talk about the change feed that we have in Cosmos DB. So this is a very, very interesting feature that we have, and basically this supports Cosmos DB works by listening to the Cosmos container for changes, and when it detects that there are changes, then outputs those, basically the list of documents that have been changed plus the change that has been done there into the change feed. And then of course you can basically, like you see here in the picture, I can have some like Azure Functions, for example, that will take care on executing some code regarding those change feeds that you have there. So a great example on this, imagine that you have an order. That order arrives in your Cosmos DB, it goes to the change feed, there's a new order, then we can have an Azure function that will do the order processing. So we'll go send to the warehouse a request for a picker just to go and pick the order, prepared physically the order, so just put stuff in the box and just label it so that it will return. So things like this. So it is really amazing the things that we can do with this. Talking still about the change feed and different operations. So things that I can do with this: sort order of items in the change feed. So in this one, I can basically, the change feed items, they come in the order that they are modified. So they come with basically that order. Then I can basically sort them into a different way. Consistency level. So we need to be careful with this, because if you're using the change feed in the eventual consistency level, you can have duplicated events in between subsequential change feed read operations. So you need to be careful with that. It's just the nature of that consistency level. I can also have change feeds in multiple region Azure Cosmos accounts. If you have a multi-region Cosmos account, if a write region fails over, the change feed will work across the manual failover operation, and it will be contiguous. Also have the TTL property of the change feed. So you also need to make sure that this has a time to leave. You can change this to -1, and the change feed will be persisted forever. So that's if of course the change feed data is not deleted. You can basically force the deletion of the change feed data. So this is just some of the things here, but one of the others that is like really important is that today we cannot filter the change feed for specific types of operations. So it will just get everything. A possible way to do this is to add a soft marker on the end of an update, and then filter that based on that soft marker. Okay, so basically another property that we can define there. So this needs to be defined in advance, because today it is something that we can't basically do yet. It's a requested feature on the service for sure, but we still don't have that. Coming up tomorrow, so we already had day 1 and day 2. We talk about virtual machines, containers, and today we talk about blob storage and Cosmos DB. Tomorrow it will be a day all about developing Azure web apps or logic apps in Azure Functions, and also we're going to talk about the API management. So a great day ahead of us. And then we still even have day 4 and day 5. We're going to talk about identity, security, and key vault. And then on day 5 we're going to talk about monitoring, content delivery networks, caching, and then event and message based solutions. So still 3 great days ahead of us. If you want to learn more about Azure for developers, you can also find the self-paced learning resources on Microsoft Learn. If you go to aka.ms/learn, you'll get there, and then you can search for some of the learning plans that you see here, like developing Azure Infrastructure as a Service Compute Solution, or develop an Azure Platform as a Service Compute Solution, developing for Azure Storage, etc. And you will find that there are more and more resources in here that you can learn to extend your knowledge. So here today we have some limited time, so of course we can't go super deep in some of the topics, but in here you have a little bit more that you can learn for sure. So I hope that I see you tomorrow on day 3.
Thank you for sharing your knowledge with us today. I hope our participants will really benefit from it. Also, as an additional resource, let me remind you that this series on developing solutions for Microsoft Azure will also be available for you to watch on demand at aka.ms/mpn/VTS. You can also download the list of upcoming VTSs and register for those in advance. So thank you all for being here with us today. We'll see you again tomorrow. Have a great day. Bye.